Professor, I have a question.
Yes, what's your questions?
Aren't there some normal distributions that have like sigma and mu as the mean and standard deviations as well?
Yeah, sigma and mu. Yes, we study in next what lecture number 4.
Oh, okay. Because I
Yeah,
was wondering why it wasn't included in this one. Because
no, not this one.
so for this one, are we like assuming
This
that
is
mu
a
is zero?
this is a functions.
So we're assuming here that mu is zero and sigma is one.
Uh they want mu and sigma because okay, just wait until when I talk about next chapter. Then I explain to you.
Okay.
Yeah, because this chapter we talk about functions. Okay, continuous distribution functions. Yeah, I will explain to you in okay after this one. Yes, okay after this lecture number 3. Yeah, you can use this one, but honestly, I can let you know, it come to the reality. People very hard to control emotions, very hard to control your psychological emotions. You especially when you win money first time, you want more and more. That's why you go back to casino. Oh, now it's 11:30. We should start the class. We should not talk about casino. Okay, where did I stop? Okay,
We stopped
assignment.
at slide 8.
Assignment 3. I will post it tonight. Okay. Some question are easy. Some question are hard. Yeah. It's due on next Wednesday.
We stopped on slide 8.
Huh?
We stopped on slide 8.
Slide number 8. Oh, then it's very, very slow. Did I do this question or no?
Oh, yeah.
Yeah, maybe I repeat again. Okay. Uh, First part, we studied discrete. Okay, discrete, they got many distributions. Okay, example that we want to study next chapter is binomial. Okay, why binomial is considered discrete? Because it do counting. Okay, like for example, how many people are lefty here? Left-handed. Yeah, you're left-handed. Okay, yeah. You guys are very lucky. You guys are very lucky compared with me. Okay, those days back my time, school is not allowed to use left hand. You guys are very lucky. Even though in Canada, it's back 70s. If your grandparents were born in Canada, the same thing. 70 or 80 years ago, school will not allow you to use left hand. Okay, either left or right is fine. It's just born to be that way. Okay, we cannot change. Yeah, a lot in the school. A lot, even though culture, a lot of culture, they okay. So let's calculate. Okay, either your left hand or right hand. Okay, usually a class like 200 people. Okay, they do the calculations. 200 people, 200 students. Do you know how many are left-handed? How many percent?
1%.
Yes, roughly 10%. Okay. Next chapter, I will talk about how they use this 10% design the lecture halls. Okay. So 200, that means it's what? Is that 20? Yeah. So in these situations, binomial is considered discrete because we're counting number of people, 2 people or 3 people or 4 people or 5 people. Yeah. So there are many discrete probability distribution, they do have many continuous probability distributions. I think altogether, it's more than 200. I'm honest telling you, this 200 probability, I might know only 60% of those distributions. I only know 60%. If someone told you that they know all the distributions, this is not true. I don't think so anyone know all the distributions. Okay. Even though this course, the most I can teach you maybe 10 distributions. Okay. So uniform is one type of continuous probability distributions. Uniform is one type of continuous probability distributions. Okay, so as I mentioned to you, the total probability always equal to 1. Why they use the term of uniform? Can someone explain to me why they use the term of uniform? Yeah, it's the same all the time. Whatever input is, yes, uniformly, yes. Whatever input is, then your output is always the same. Okay, no matter what input that you put. Okay, so let's say here I put A, B. Okay, what is the height? You know that the area under the curve is probability, or you use integrations, so how do you calculate this one?
The area of a rectangle?
1. So what is the value for this one? What's the value for this one? Anyone can answer my questions? If let's say start from A to B, what is the value for the probability? Okay. What is the name for this one? What do you call this one? Just now I asked one student. You always save your file in PDF form. Is that right? I remember the joke. Okay, this is PDF. So PDF stands for what?
Density function?
Say again?
Probability density function?
Yes, probability density function. Okay, so this is what is the value for the probability density function? No matter what is the input, what is, yes, 1 minus B, 1 over B minus A. Yeah. Okay, how do you know it's 1 over B minus A? Because the total probability always equal to 1. So the length of this one, a simple that you study in elementary school, the length of this one multiplied by the length of this one must be equal to 1. Yeah, okay. So now the uniform is 1 to 4. So the value here is 3y is 4 minus 1. 4 minus 1. Yeah. So as I mentioned to you, okay. In what situations these two are the same? In what situations? Continuous. Yeah, thank you for continuing. So it's okay. You want to put equal sign, that's fine. You don't want to put equal sign, that's fine. Yeah, okay. So now, if you look at this one, okay, here is 1 to 4, according to the questions. Yeah, okay. So the x value less than 1, if your value less than 1, what is your probability value? Is that 0? If your x is more than 4, your probability value also 0. That's why here, 0, 0. Only this part, 1 over 3 is 1 to 4. Okay, this is one way to write the answer, or the other way is, this one's clearer. Okay, the other way is just write down, okay, f of x, 1 over 3, or 0 otherwise. That's fine. Okay, both are okay. But this is clearer. This one, or people know that, oh, when x is less than 1, the probability is 0. Okay, When x is more than 4, the probability is 0. Yeah, okay. So now the question is to calculate the probability. Okay, the area under the curve is the probability. Okay, the area under the curve is probability. So when we talk about the area, for calculus, we use integrations. Okay, so here I start from, they say, start from 2 to infinity. Okay, so 2 to 4, we put 1 over 3. After 4, it's 0. Okay, so when you do the integration, you get 2 over 3. Yeah, so this 2 to 3, 2 to 3 is in this range. So we use 1 over 3. Yeah, so here I put 2, here I put 3, and then you do integrations, then you get 1 over 3. Everyone okay? Yeah, so we study PMF and CDF, and then for continuous, we study what? Oh no, PMF. Okay. Maybe I should write up. For the discrete, we study PMF to CDF. We do sum. Is that okay? For continuous, we study PDF. This is Emma. The CDF, we do integrations. Yeah. Okay. So it's still the same thing, cumulative distribution functions. Okay, this one to show to you the difference. One is sum, the other one is continuous. Okay. So the opposite, if you want to go back, then what we have to do?
Take the derivative.
Yeah, derivative. Okay, I put D, derivative. The same thing, this one go back, we do minus. Yeah. Okay. Okay, I would like to ask you, do you agree with this one or not? If I give you a piecewise function for the capital F, probability of A to B is you substitute into your CDF, okay, B minus A. You can get the value for the probability. Is that okay?
Yeah, I think it makes sense because I think it's like the definite integral that we do f of b minus f of a.
Yes. Okay. Now, let's go back. Okay, now, is that okay? I'll let you do it by yourself. Okay, now, convert this one to CDF. So you have to do the integration for me. Can you? Or you want to do it together? Okay, before I start doing this one, do you agree that at the end, either discrete or continuous, the last one, because cumulative, that means you add up the probability value. Is that right? So continue to do it until a certain stage. Do you agree that the total probability always equal to 1? Either discrete or continuous. If you calculate CDF.
They all equal to 1?
Sorry?
They all equal to 1?
Yes, both always equal to 1. Both always, because you're adding up. You're adding, become more and more and more and more until a certain stage, you need to stop. Okay? To 1. Yeah. But how about F? How about what? PMF or PDF? Do you think that, let's say I put in a table form. And this one, this one always equal to 1 or no? Can this value, the probability value for the last one is equal to 1? No. But when we add up all the probability, then yes, you add up all the probability is equal to 1. Okay? So make sure you differentiate with the small f and capital F. Because capital F, you total up the probability. So until a certain stage is equal to 1, but not this one, not this one. But this one, the situation slightly different. You total all the probability, then yes. Okay? So now let's do these questions. Okay, you agree that small f to the capital F, we need to do integrations. So first, we do x less than 1. X less than 1. So the capital F is equal to what? Negative infinity to 1. Yes or no? Yeah. So according to the F, the small f, x less than 1 is what? 0. Okay, integration of 0, is that always equal to? 0, yes. Okay, good. Okay. Then the next one is 1. Okay. According to the calculations, why I start from negative infinity? Okay. Yeah, of course, negative infinity here is here, this one, the integrand is 0. But why I still want to show to you is negative infinity?
Because anything less than 1 is always going to be 0.
Huh?
Anything less than 1 is always going to be 0. If x is less than 1, then the probability is still going to be 0.
Yes. But my point here, why I start from negative infinity? Why don't I just start from 1 to 3? See the question, here I put 1 to 3. Why don't I just start from 1 to 3? Why I want to start from negative infinity?
Because
always remember, this is cumulative. This is cumulative. Cumulative, that means is what? You total up to what? Up to 3.
Up to 1. 3.
Yeah, here up to 1. But the entire question is this part. The second one is up to 3. Is that right?
So, Professor.
Less than 3. Less than 3.
So, Professor, okay. If we do the cumulative, we need to always from the negative infinity.
Yes, because you start from the beginning. Okay, when you do the capital F, no matter discrete or continuous, we always start from the beginning. Yeah. Yeah, because here is 0, yes. Yeah, okay, and then the next one, because we do not know where to stop. That's why I put 1 to x, because they say less than 3. Yeah, okay. So now, oh, why I put 1? Because here, this is piecewise function. This is less than 1, 0. From 1 to 3 is half. Am I answering your questions? Yeah, we always refer to this one. Am I answering your questions? I didn't respond. Because here, because less than 1, after more than 1, the f value is different, become half. The output is different. This one, you look at here, x less than 1. If x is 2, which one do you choose? If x is equal to 2. The student asked me questions. Can I ask you a question back? If they say x equal to 2, you choose the first line or second line?
Second line.
Yeah, second line. Does that make sense? Yeah. So because here, we have to split into what? 1 and then 1 to x. Yeah. So now we do the integrations. Oh yeah, if maybe this is not zero, okay, but most of the time zero. Okay, if this is not zero, okay, for uniform, the first one is always zero. Okay, if not, then you have to do the integration. Yeah, okay. So are you okay with this one?
Yeah.
Yeah, okay. So now, next one is up to 3. Sorry, this is less than 3. This is x is more than 3. Okay, x is more than 3. So more than 3, that means is what? Do you know where to stop? No. So then we put x. Okay. So now up to, we need to use 3 of them. Okay, we need to use 3 of them. Yeah. So the first one is negative infinity to 1. The second one is from 1 to 3, and then this one is 3 to the certain value. We don't know what, because they say x is more than or equal to 3. Yes, this is to find the capital F, CDF. From PDF to CDF.
I have a question.
PDF, we want to find the, given PDF, we want to find CDF. Am I answering questions? So PDF to CDF, we need to do integrations. If the opposite is derivative. Everyone okay? Just help me to check my, but definitely I know my final answer is correct. Okay, but the process, is it right? Just help me to check.
Yeah, it's right, because since the second line
yes,
is equal to 1.
Lecture 3, part 1, yes. Whatever that you ask me is correct. We have to sum it, yeah. My integration is right? Okay, so now you want to use, you want to write in CDF form. Slide number 8, slide number 8. Where is this slide? Just give me a second. Huh? Oh, slide number 8, just to find the priority value. This is to find priority value. Now we want to find capital F. Of course, capital F help us to find priority value easily, because the formula, where is the formula? Yeah, okay, it helps us to find the priority value. So the difference between slide 8 is to find the priority. Okay, now you want to find, yes, now you want to find CDF. Yeah. Okay, so let's transfer everything. 0, x minus 1 over 2. Yeah, then it's 1. Here, for the capital F, the final one always has to be equal to 1. Yeah. So this is okay for everyone? Yes,
Hi,
okay.
Professor.
So we want to draw the diagram. What do you think about this one? Do you agree with this diagram or no? If yes, why?
Yes, because the area under the graph is going to equal to 1.
Okay, yes. Why? I think almost. This is capital F. Your explanation almost. Your explanation is small f, yes. Capital F, you need to do slightly of modifications. Why? Okay, Why the diagram something like this one? Can the diagram like this one? Keep up. Non-stop. I put an error. Is that possible? No. According to our CDF, I need to use different color. Okay, this is your F value. According to this one, should I put a small f or capital F? Capital F? Okay. Do you agree that, okay, even though I don't have the piecewise functions, I definitely know that this value is 1. Yes or no?
Yeah.
Yeah. Okay. So we have to be careful with the small f and capital F. Okay. For the small f, the area under the curve is a probability value. Yeah. Okay. This one is capital F. Okay. The maximum here is 1. Okay. We need to draw the line. Okay. Whatever line that draw, you have to stop at 1. Okay. Have to reach 1 and stop at 1. Do you know how do I get this one? The first part, second part, and third part. How do I get the first part, second part, and third part? No, we cannot, because here you up to, because CDF is you total up your probability. You total until what? 1. So you cannot go beyond 1. No. So how do I get this line, the first line, second one, the third one? I think someone explained to me just now. I missed the message. Can someone explain to us how to get first part, second part, and third part? Yes,
integrating.
Other than that, what? Okay, let's say I don't know how to do integration. So how do I get this line? Okay. Someone had to give me what?
Since when x when x smaller than 1, it's equals to 0, and then this is a linear function about dx.
Yes. Okay. Here, don't mix up with the small f and capital F. Okay, at the beginning, I draw to you this one. Okay. I told you that this is B minus A. Okay, so this is B, this is A. This is small f. Now, yes, small f, this is the area under the curve have to be equal to 1. If this is small f, now this is capital F. Cumulative distribution functions. So cumulative distribution functions, so the value here had to be 1. This one value not necessarily had to be 1. Do you see the difference between capital X and small x? Yes or no? Don't mix up with these two diagrams. I'm very sad. Last time I taught in other university, they still all mix up with these two diagrams. Okay, are you okay with the small f and capital F? Small f, then the area is 1. Okay, but the value here, seldom we can get 1, okay? But for capital F, yes, because you total up your probability, the meaning of cumulative, you total up the probability up to 1. They cannot go beyond 1. So this value is have to be less than 1. And under special case, you can get 1. Okay. Most of the time, I can say 99.99999% is less than 1. So far, so good? Yes. Okay. So now, let me ask you a question. You are okay. You're better than me now. Okay. Do you know what did I get for this course? 28 years ago, I took this course.
Above 80.
I didn't get A for this course. I didn't get A for this course.
Oh,
I believe many people can get A for this course because I did explain to you a lot of differences between those things. So you sure you can get A, at least A? Why not? Okay. So be careful with the difference between small f and capital F. Okay. Here, capital F refers to cumulative. So then you total up your probability until 1. You cannot go beyond 1. Okay. So this one refers to the probability value for the each input, not each x. So are you okay with the difference between the first one and the second one? I need respond. Yes, okay, thank you. Okay, so now go back to this diagram. How do I get the line, this part, the second line, third line? How do I get this one? My internet had problem and got disconnect. Could you please explain this again? Okay. The first one and second one are different. The first one, the Y is referred to the capital F. This one, the second one, the Y referred to the small x. Yeah, okay. So the meaning of capital F, cumulative distribution function, refer to you total up the probability, cumulative, you total up. So you total until 1, okay? Here, I can say 99.99% you can get 1, okay? You can get 1. So the value here, you cannot get 1. Okay, this value refers to your x value. When your x is equal to what is the probability? When x equal to 2, what's the probability? X equal to 3, what's the probability value? Okay, here, difference. Here, let's say here is 2. Here is 2. Okay, the meaning of here is up to 2, where your variable up to 2, what is the probability? Up to 2. Up to 2, that means is what? Negative infinity to 2. Is that okay? Is that good for everyone? Okay, so the first line is to get from the first one, 0. The second one, this one, you get from x minus 1 over 2. This one, you get from 1. When f of x equal to 1, this is a line. Is that okay? Everyone okay with the diagram? Yes, okay, good, thank you. Okay. This one, when you do probability from CDF, for the continuous cases, do you agree that, okay, the third one, okay. I just pointed, all are easy to understand the third one. Why I want to point out the third one? Because it's very useful. It's very useful. Maybe A, I change to a number to 2. Okay. So when you want to calculate x is more than 2, okay, if this is continuous, both are the same. Yeah, if this is continuous. But the problem is, if let's say in this class, okay, you guys are majoring computer science. Is that everyone majoring computer science here?
Yep.
Yes? Yes? Okay. Not everyone. If you're
Some
not
in
major
math.
computer science, well, what's your major?
Some in math.
Math, like me, okay. Yeah. So that's it. A research showed that, okay, a survey showed that, okay, students graduated from computer science, they can get a job within 5 days, within 5 days, within 5 days. So 95% of the students got job within 5 days if they got a computer science degree from York University. Okay, so now let's say we got 500 students. 500 students. So we want to calculate the numbers. What's the probability that more than two students getting the job? More than two getting the job within 5 days. More than two, that means start from what? X equal to 3, X equal to 4, X equal to 5, until what? X equal to 500. That means we need to do calculation how many times? There are many. I think computer science is not a big issue now. Okay, you can explore into the big data. Computer science is very easy to get a job. The same thing like statistics. 30 years ago, how did you get a job if you finish your degree in statistics? Okay, so calculation, you need to do a lot. Okay, do you have any shortcut to do it? We know that our total probability always equal to 1. Yes or no? So then we do 1 minus what? X less than equal to 0 minus X less than equal to 1 minus X equal to 2. Yes or no? Yes. So the same thing, the concept applies here. Yeah.
Isn't it just a complement?
Yeah, just a compliment. Yes. Thank you. You made my life easier. Yes, just a compliment. Because the total probability equal to what? Just a compliment. Yes. Okay.
Wait, Professor.
Yeah. For continuous cases, the X minus 1 is equal to this one. As I mentioned to you, okay, these two are the same. Yeah. Why did you include 2? Oh, no, this one, if I'm talking about discrete case. Oh, are you talking about discrete or continuous? Continuous, both are the same. Because I spend more than 2 hours to complete my project or my assignment tree. I spend more than 2 hours. More than 2 hours, not necessarily have to be 3 hours. Yes or no? It can be 2.00000000001. Do you want to write this number or you want to write 2? Of course, you want to write 2. Okay, for continuous, both are the same. Okay, I give you this example, discrete. I just want to tell you that, okay, use the complement to do calculation is easier sometimes. Okay, sometimes we use a complement is easier. Otherwise, you need to go through a long process. At the end, you get the same answer, but you need to spend time. Our test always got 1 hour only. Yeah, so far so good. Now, when do you study graph? Grade 9?
Yeah.
Yes, okay. Now we go back to grade 9. Okay, can you help me to draw the graph? Don't worry, you made mistakes. Okay, just like give you a chance, give yourself a chance to draw the graph. So what should I put on X? What should I put on Y?
So from X less than 0, we put
Y-axis.
X is less than 0, we put 0 there.
No, give me a label. I should label this one. Can I put X, Y here? No, I need to put something. What should I put here?
X.
X, okay, how about this one?
Y.
No. Capital F. Okay, thank you. Because the question asks us to draw CDF. Okay. Do you agree that X value can be negative value? Yes.
Yep.
How about capital F or small f? Can we get negative? No. Okay, so we can extend the line, but we cannot extend the vertical line. Okay, horizontal line, yes, we can extend to this side. Yeah, okay. So 0 to 1, 0 to 1. Okay, let's say here 0, here 1. Okay, so the line is what? F of x equal to x. So the line should be what? Y equal to, similar to y equal to x. Yes, okay. So the line is something like this one. Yes or no? Okay,
Yeah.
After that, then it stop. Okay, then this is 1. Okay. Yeah, let me see. No, I didn't include the graph. Did I give you a graph? No. Okay.
Not for this one.
No, so yeah. We cannot accept 0 and 1. You want, you can draw an open circle. Is that okay? You don't want, it's fine. Yeah, okay, open circle. Yeah. Yeah. Okay, now example from CDF to PDF. So can you convert this one to small f? Can you help me to convert this one to a small f? What should we do?
Take the derivative.
Derivative, yes, thank you. Okay, so the first one is less than 0. The derivative of constant is 0. Okay, the second one is x. Yes, derivative of x is 1. Okay, then the third one, 1, a constant, you get 0. Okay, so now we put down those values, 0, 1, 0, you put it here. Yeah, so now you total first one plus the second one plus the third one. Is the total equal to 1? Yes. Okay, we can total this item. Okay, the first item, second item, third item. If this is small f, if this is capital F, do you agree that the last term, it had to be 1? Yes or no? Okay, I repeat my questions. For the small f, the first item, second item, the third priority value total up equal to 1. But for capital F, the last one have to be equal to 1. Yes? Okay, good. Thank you. So now, here, I need to change it to small f. From 0 to 1. This value is 1. Yeah, okay. So from 0 to 1. So it's something like this one. So the area under the curve is equal to 1. Not for the capital F. Huh? Don't mix up with the capital F. Small f, yes, the area is equal to 1. Yeah, so this area equal to 1. Yeah. Yeah, I put the broken line. That means it's not included 0, not included 1. But that's fine. You want to include, not include, is fine because this is continuous cases. Yeah. Okay. Should I let you try these questions? This question is small f. Small f. So the only way to do is what? Integrations. Yes? So the integrations from 0 to 0.5 to 1. Okay, so can everyone do this question for me? Can everyone do it for me? I see how many more pages to go. It's quite fast. I think I can finish this one today. Then I can move to. Everyone okay? The integrations. So from 0 to x. Okay, the integrations. I think you still remember the integration. So this integration, how do you do this one? Integrate the differentiate the top one, -3, then you bring it below. Okay, so turn out to be -e to the -3t. Then you prime into it, then you get 1 minus. So do you agree anything below 0, below or equal to 0, your capital F is equal to 0? So now we put in this form. So x is less than or equal to 0, 0. And then this one, I got from, I got from these calculations. I put it here. So now, if we got capital F, then it's quite easy. We don't need to do any integration anymore. You plug in 1 and 0.5. 1 and 0.5. Where did I get this formula? I showed to you earlier. If we got capital F, we want to calculate probability. It's just sum into when x equal to 1, when x equal to 0.5. So I need to substitute inside here because here it starts from more than 0. Yeah. So after doing substitutions, I simplify, I get this one. So the same thing for the second one. This is okay? Yes or no? You only can do the substitution if this is capital F. If this is not capital F, no. If they say this is small f, what should I do? If I want to calculate the probability. Can someone answer my question? I repeat my questions. If they say this is small f, let's say this is small f, I want to calculate probability. Yes, I need to use integration. If this is capital F, I just substitute inside the function, that's enough. Yeah, so no mix up with the small f and capital F. Yeah, the same thing when you draw the diagram, don't mix up because I still remember those days I studied this one, I will mix up with the small f and capital F because those days PDF are not so popular, okay? From the questions, my question asks you 0.5 to 1. From my questions, because you see here, yeah, 0.5 to 1. This is okay? I don't know how many times I ask you okay or not. Because I got the experience, I all mix up with the small f and capital F. That's why I couldn't get B+. I didn't tell you my grade. Okay, I couldn't get A. Okay, so don't mix up with the B, or not B. Don't mix up with the small f and capital F. Okay, the way of getting the probability value, if you are given you small f, you want to find the probability value, you need to use integrations. If they give you capital F, then you just sum into the functions. Yeah. So this is additional example. I think my calculation is okay. I think I don't have typo error. Come in to check it. If I got any typo error, let me know. So far, so good. Lecture number 3, I got a third part, but I do not want to teach you now because the part is very dry. Very dry. I want to keep it until the end of semester. Okay, the end of semester, then I explain to you because the part is very, very dry. Okay, we need to use humidifier. It's very dry. So I keep it first. The third part of lecture 3, I keep it first. I do not want to teach you. The test 2, I'm not going to ask you because I did not teach you. Yeah, okay? So now we move to lecture number 4. Oh, I think I got time. Just give me 2 minutes. Maybe we should do the conclusions. Now 12:20. Okay. If I bring out the file. Okay, let's do a conclusion now. Just give me a second. Next chapter, lecture number 4. If you see the title, I combine binomial. The next chapter, I combine with binomial and normal. Yes or no? Can you look at your lecture note number 4? It said I combine together. I got reason why I want to combine together. The title is binomial and normal. Yes or no? Yeah.
Yeah.
Why I want to combine together? Because binomial, bicycle, 2 wheel, 2 outcome. This is discrete. This is what? Continuous. Just give me a second. Just give me a second. I combine together because they are best friends. Okay, do you have best friend in your university? Yeah, I like to be, I'm lonely. Okay, I know friends. Okay, I'm old and no friends. Okay, yes, I like to be your best friend. Why not? Okay, binomial and normal are best friends. Why? Because they got connection. They are very, very good friends. Okay, one is discrete, one is continuous. So we're going to talk about friendship on Wednesday. Okay, we talk about friendship, how good they are. Okay, yeah. Okay, before we talk about move to Wednesday, let's do a conclusions. We only got 7 more minutes. I need to move to the other class. Can you give me one sentence that what you learned from me today? Yes, in order for you to get A, not B plus. Okay, yeah. So you have to be careful with the small and capital F, especially when you draw the graph, when you calculate the probability. Yeah, big F, we just substitute, yes. Small f, we have to do integration, yes. The graph, capital F and small f, yes. Yeah, small f, the y-axis you cannot get. Very hard to get 1. Okay, most of the time the value is less than 1. Okay, for the capital F, the graph is 1. Yeah, okay. So I stop here. I see you again on Wednesday to talk about friendship. Okay, yeah. If you want to be my friend, I'm more than welcome.